This is worksheet 8.6 for Algebra 1, exponential decay. So state whether the graph is exponential growth, exponential decay, or neither. This is exponential decay. It's decreasing rapidly. Same with here, it's decreasing even more rapidly, so a larger percent decrease. Number 3, you'd say, well, that looks like exponential decay right there, up until, whoop, there when it goes up. So 1 and 2 are, this is not, and then this would be exponential growth. Things are increasing at a non-linear rate, non-straight lines. So where the equation shows growth or decay, the key is the value inside the parentheses. If it's greater than 1, it means it came from 1 plus the rate, which would be growth. If the value inside the parentheses is less than 1, it means it came from 1 minus the rate, which is exponential decay. So this is going to be decay. Because the factor is less than 1, whereas this would be growth because the factor is greater than 1. And you can try 7 and 8. Good luck. If you take 8 divided by 3 in your calculator, you can figure out what is in the parentheses there. For the decay models shown, identify the initial amount, the decay factor, and the percent decay rate. So our initial amount here is 6. Our decay factor, or our multiplier, is 0.98. And that means, so since it's decay, we took 1 minus the rate. So what is the rate? And I like to think of this as $1 minus how many cents gives me 98 cents. $1 minus 2 cents is 98 cents. So then convert this from a decimal to a percent. That's the same as 2%, which is equivalent to 0.02 as a decimal. So here, initial amount is 7.4. We're multiplying that by 0.23. So because it's decay, because the factor is less than 1, you need to think about $1 minus what is 23 cents. You could also take the difference between 23 cents and $1 to figure out this value. So the decay rate is 73%, to convert the decimal to a percentage. If it helps for number 11 is a little bit tricky because the initial amount is the multiplier out in front here. And I don't see a number, so what is it? It's a 1. And then you could also think of what's in the parentheses as 0.20. Perhaps think of it as 20 cents. So that's your decay factor. So now you're thinking, again, 1 minus what? 1 minus how many cents is 20 cents. And then convert that to your percentage. Good luck on 11 and 12. Let's see here, anything tricky? I don't know. I'll do number 15 maybe. So your initial amount is 2/3. Your factor is 0.702. So then to figure out your rate, I would take the difference between these two numbers. And when I punch that in the calculator, 1 minus 0.702, I get, so I get it in my calculator, I did 1 minus 0.702, and it equaled 0.298. That's going to be my decay rate, which would be the same as 29.8%. You buy a used car for $12,000. It depreciates at 15% per year. If this trend continues, write an exponential decay function that models the profit in dollars over time, or the value of the car over time. Car value. So it's decay, so it comes from this, our initial investment times 1 minus the rate raised to the time. So that would be $12,000 the initial investment in the car, and I'm subtracting 15% from 1, but let's convert that to a decimal, so 0.15, and that all gets raised to the power of t. So what's the value of the car after 1 year? So $12,000. Really you could just take 85% of the car value because that's what you get to keep. Every year you get to keep 85%, and I get that 85% because that's my multiplication factor. 1 minus 15 cents is 85 cents. And I'm only raising it to the power of 1, so I don't really need to do the power of 1 because it's just itself. Oofta. It's going to be $10,200. What's the value of the car after 5 years? Again, every single year I lose that 15%. So you could either type in what I just wrote in, or you could do this. They both will give you the same answer. Ouch, I'm getting $5,324.46. I'll let you try number, actually I think I need to do this one in order to answer another question. Right, so business A has 4,000 employees in 2001. Each year the number of employees has decreased by 2.1%. And then here they ask you, so I'm gonna let you make that equation. How many employees will the business have in 2017? The big thing there is the 4,000 employees occurred in 2001. So every year after that, we're losing 2.1%. So the difference here is 16 years. So in the equation that you created for A, your time would be 16 years. So 16 years later, after 2001, when we had 4,000 employees, how many do we have now-ish in 2017? The table shows declining employment for business B, a different business, over time, where T is the number of employees since 2005. So this is 2005, whoa, right here. So I noticed that these are multiples of 9. 9 times 700 is 6,300. 9 times, these are multiples of 7, just kidding. 7 times 1,000, 7 times 900, and this is a difference of 700. And that's 10% of 7,000. So here I've lost 10%, minus 10%. And it's actually the same way there as well. You lost 630 employees going from year 2006 to 2007. So it's also minus 10%. So it's a consistent rate of change every single year. So what's the initial amount? It's 7,000 employees in the initial year, 2005. What's the decay factor? We get to keep 90% of them, and that means the rate is 0.10 or 10%. Write an exponential decay function that models the employment of business B over time. So our initial amount is that. We take 1 minus 10% as a decimal, or we can actually just consider what we get to keep. We get to keep 90% of the employees. Ooh, geez. And then use the information from the last two questions. Which businesses will have more employees in 2017? We'll compare your answer to, I guess, 18B to what we get for 2017 here. Now this equation is created with our initial year being 2005. So what's the difference between 2005 and 2017? It's 12 years. So I need to now make my T be 12 years. That'll give me the number of employees. And now I just need to compare that to my previous answer.